Today we will talk about the permissions in the Linux system. So first of all, Linux is a multi-user operating system, which means that multiple users can use it at the same time or in different times. And in order to ensure that these users have control on their own files and directories, Linux implements a permission system, a system of permissions. And to make this system of permissions easier, there are also groups of users. So let me try to make a picture. We have here one group of users. There are some users inside it. There are several users inside this group of users. Let's say that we have another group of users. Maybe one user can be in two different groups. And let's say that there is also another group of users. And if we give some permissions to one group, then all the users in this group have these permissions. So there are individual permissions for each user. There are group permissions for members of one group. And there are also some permissions for other users that are outside these groups. So, for example, okay. So for each file, we have three different sets of permissions. One are the permissions for the owner of the file. One set of permissions for the group to which this file belongs, and one set of permissions for the other users that do not belong to this group and are not the owner. And also it is the same for directories. So one set of permissions for the owner of the directory, one set of permissions for the group to which this directory belongs, and another set of permissions for the others that do not belong to the other users that do not belong to this group. And when I say a set of permissions, they are read, write, and execute. Let me try to make it more visible. So each set of permissions is read, write, and execute. And these are, for example, for the owner. And we have another set of permissions, read, write, and execute for the group, and another set of permissions, read, write, and execute for the others. So for each file, we have these 9 permissions: read, write, execute for the owner, read, write, execute, read, write, execute for the owner, read, write, execute for the group, and read, write, execute for the other users. And it is the same for the directories. Each directory also has these 9 permissions for the owner of the directory, for the group to which the directory belongs, and for the other users that are outside this group. Now, if a permission is missing, if some permission is missing, it is represented by a minus. So if it is read minus execute, it means that it has read and execute permission, but it does not have the right permission. Or maybe it is minus minus x. So there are 2 different minuses here. So maybe minus minus x. So it has only the execute permission, or minus minus minus. The others have no permission. in this case. So these are the set of permissions for the others. And for example, for the owner, it can be read minus X. It has read and execute permission, but does not have write permission. Okay, let's see some command examples. First of all, let me share my screen. Let me create a dummy file or a test file. I can create a test file with this. We see this food.text. If I list with the option -L, here we have the permissions of this file, and we see that we have read, write, and no execute for the owner. We have read, no write, no execute for the group, and we have read, no write, no execute for the others. Now, who is the owner? The owner is this one. User1 is the owner of this file, food.text. Why is user1 the owner? Because user1 has created it. So I created it as user1. So I am the owner of the file. And the group of this file is a student. Why the student? Because student is the default group for user1. User1 has this primary group, and he belongs to other groups as well, may belong to other groups as well, but this is the primary group or the default group. So when I create a file, it belongs by default to the default group of the owner. And the others are all the other users that do not belong to the group student. And we also see this this minus here at the beginning. This minus it has a special meaning. In this case, it means that it is not a directory or a special file or something like this. For example, if I create a directory and list, okay, list the permissions, I see that for the directories, the first character is D. For the files, for the normal files, it is minus. So if it is a D, it means that it is a directory. If it is minus, it means that it is a normal file or regular file. Because there are also some special files that we will see later. We can use the command change mode. We can use the command change mode to change change the permissions of a file. For example, if I use, I can use this command change mode 600 food.text. I am changing the permissions of this file food.text. Let's check the permissions of this file. Now, what does this 600 mean? These are three numbers. We have the number 6, the number 0, and the number 0 again. And these are octal numbers. So numbers in the system with base 8. And how do we represent 6 in the binary system? In the binary system, 6 is the 6 is 0, 0, or no, 1, 1, 0. 1, 1, 0. So this is a 4, this is a 2, and this is a 1. So 4 plus 2, 6. So in the binary number, in the binary system, we write 6 like this, 1, 1, 0. And we write 0 like this, and we write 0 like this. So these are actually the permissions. If we have a 1, we have this permission. For example, here we have read, write, and no execute, 1, 1, 0. And then we have 0, 0, 0, no read, no write, no execute, 0, 0, 0, no read, no write, no execute. And we can use this way to change the permissions. And for example, if we want to make to give all the permissions, then we will do it 1, 1, 1, for example. And here, for example, read, no write, and execute. And let's say just read and no write and no execute. Now 1, 1, 1 in as an octal number, it is written as a 7, and 1, 1, 0, 1 is a 5. It is written as 5. 1, 1, 0, 0, it is just a 4. Because remember, this is the equivalent of 1, this is the equivalent of 2, and this is the equivalent of 4. So we have just a 4, we don't have a 2, we don't have a 1. It is 4. And here we have 4 plus 1, it is 5. And here we have 4 plus 2 plus 1, it is 7. So if in order to give these permissions to the file, we can use this command change mode 7, 5, 4, 2.text. And let's check what permissions the file has now. So it has all the 3 permissions for the user, only read and execute for the group, and only read for the others. Another way to change the permissions is like this, or this command change mode can accept an argument like this, u minus x. So we see that this foo.text now is executable by the user, by the owner, and executable by the group. Now, if I say u minus x, it means from the user or the owner, remove the x permission. So minus x means remove x. And if I check the permissions, now we don't have the permission x for the user. Or if I say, for example, plus x, add the permission x for the user. So we have the permission x back now. And I can also say from the user and the group, from the user and group, remove the permission x. So we have removed the permission x from the user and from the group. Or I can say from the user, from the group, and from the others, remove the permission x. And actually, when we have to say user, group, and others, we can use instead just all. So remove the permission x from all, or add the permission x, to all. So now all 3 sets of permissions have this executable permission. And if we say all, then we can remove this a. And if we just say plus x, or if we just say minus x, it removes it from all, or adds this permission to all. for example, -x will remove the executable permission from the user, from the group, and from the others. So let's check. So all the x's are removed. And we can also combine. We can also combine several actions in one and separate them by comma. For example, user plus x, add x to user, and group other minus r. So it is going to do both of these actions, add x to the user and remove r from group and others. And if we check, so we have added back x here, and we have removed the read permission from group and others. Now we will see something that is called umask. This command umask controls the default permissions given to a file when it is created. And if I just type the command, umask, it is giving me these numbers. What do they mean? First of all, this is for the first bit, and the 0, 2, and 2 are for the owner, group, and others. Now, what is 0? What does it stand for? 0 is 0, 0, 0, and then 2 is 0, 2, 0, 1, 0, and the other 2 is 0, 1, 0. Now, this mask means that remove this permission from the default permissions of the file, and this is the right permission. So this umask 0022 by the removes the right permission from the group and from the others. So when we create a new file, it has some default permissions, but this umask is going to remove the right permission from the group and from the others. So let's remove this foo.txt and then create it again. So it is not here. Create it again. So by default, it will give read and write permission to all the groups. So to the owner, to the group, and to the others. But because we have this one here, it is removing the right permission from the group. And because we have this one here, it is removing the right permission from the others. And so when we create a file, by default, it has these permissions: read write for the owner, only read for the group, and only read for the other users. So if I change umask and say, so now this is not masking anything. So if I create a file, if I create a new file, it will get all the default permissions. So let me remove this file foo.txt and create it again. And check the permissions. So it has read write for the user, read write for the group, and read write for the others, for the other users. Let me restore the umask to its default original value. Okay, I can test it again. Remove foo.txt, create a new file, check the permissions. Okay, this is the default behavior. But let's say that I make umask just for fun or for testing. I make it 777 0777. It means that it is going to remove all the permissions from the file. So let me remove the file and then create again a new file. Check the permissions. So this 7 means 111. Also, this is 111. So it is going to remove all 3 permissions. It is going to remove or to mask all the 3 permissions from the file. So when I create a file, it just has no permissions at all for anybody. Okay. Now we will see how to create new user accounts. And new user accounts are created with the command user add. User add in order to add a new user. So let's see how this command can be used. So user add, this login is the username of the user, and then some options before it. And the options are listed here with the meaning of each option. And this option -m means create home in order to create the user's home directory. And the option -s is for the shell, which is the default shell of the new account. So let's create a test account. User add. I will call it test1. So the username will be test1. And then with the option -m, I tell it to create a home directory for this user. And then with the option -s, I'm telling the command to use bin bash as the default shell for this user account. And now I'm pressing enter, but it says permission denied. The permission is denied because only the super user can create new accounts. So how do I get super user? How can I be a super user? I can use this command. I press Ctrl A, but I'm adding sudo. So I'm running this command with sudo in front of it. Sudo means super user do. So do this command as a super user. Sudo user add, etc. So this prompt is asked by the sudo command, and I'm giving the password of user1, my password. And now the command was executed without complaining. Let's see at the home. Now I got this test1 user account, a new user account. And if I check what is inside this home test1, Oh, it says permission denied, cannot open directory. Why? Because this is another user and I'm user one. I cannot see the content of the directory of another user. But I can see it if I run the command with sudo, Control A, sudo, because now I become a super user or I become an administrator. So I'm running this command ls with administrator permissions. Actually, it is empty, but I can use the option -al just to see that the command is working. So it is empty, but it has some hidden files which start with dot. So now I can see the content of this user home directory because I'm running it as super user. And in this time, it did not ask me for a password. Why? Because I gave the password here. And once I give it, it remembers it for some time. For example, until I log out or for 10 minutes or 5 minutes or something like this, I can do sudo command again, and it is not going to ask for the password. And later, after the timeout expires, it is going to ask again for my password. So I am kind of authenticated right now, and it remembers it that I belong to the, I can give sudo account. But I should set also the password for test1, because if I try to log in, I know the username, but there is no password on this account. And I can give it with, I can set the password of this account with the command password test1. But again, I have to use sudo in front. Sudo password test1. I'm giving a simple password, test1. Password updated successfully. Anton, go ahead. Do you have a question?
I wrote in the chat what I got.
Okay, okay, yes. Anton has tried to create a new account, but it has failed. Now, why? It has failed because the user of Tony, user Tony, cannot use sudo. Now I will explain this, and I will fix this. So first of all, let me become a super user or admin. Sudo su. So the command su means become a super user, but I cannot execute this command until I have super user admission permission. So I give the command sudo su, become a super user. And now I am a super user, or I am root. Who am I? I am root. Root is the super user of the Linux system. Super user or administrator. The supreme administrator or absolute administrator of the Linux system. So, and also you notice a change in the prompt. The prompt is different for the super user in order to remind the user that now you are a super user and you should be careful what you are doing, because there is nothing that the super user cannot do. If you by mistake damage something, then there is nothing to prevent you. You can destroy the system if you do some mistake. And now back to giving sudo permissions to users. So there is a configuration file which is called etc sudoers. Let me check this configuration file first. And now it is saying that all the people in the group sudo can do everything as an administrator. And also the root can do everything and admin. So if I want to give sudo permissions to a user, then it is enough that I add this user to the group sudo. And now let me try with user Tony. Add user Tony sudo. So I'm adding user Tony to the group sudo. So adding user Tony to group sudo. Now that the user Tony is in the group sudo, it can run commands with sudo and another command, and it will ask for the password for the first time, and so on. Now let me add Andri as well to the group sudo. So add user Andri to the group sudo. User Andri now can use sudo as well, and I can also check less group. This file etc group has a list of groups and what users are in each group. So I see here in the group sudo, there is the user Ubuntu, which is by default. It is user one, the user that I'm using, and the other two users, Tony and Andri, that I added. I've just added. Now back to my normal user account, user one. Now Anton and Andri should have no problems using sudo and some other commands. So I mentioned the group etc password, etc group, and here here I can see the groups and the members of each group. For example, and the list of users is on the file etc password. So here I see this new user that I just created, test1, and it is using this home directory, home test1, and it is using this shell, default shell, beam bash. However, in this file, we see that the password is not stored in this file. Why? Because it is kind of public. So I can see the content of this file. Every user can see the content of this file. So it is not wise to save the password in a file that can be seen by everybody, every user of the system. The passwords instead are saved in the file etc/shadow. So let me try to check the content of this file. It says permission denied. Only the administrator or the administrators can see the content of this file. So let me try with sudo less etc shadow, and here I have the password. For example, password of user one is this one, but it is encrypted, of course. So even if I see it, I cannot find right away what is the password, but it is possible to find it. If you know the encrypted version, it is possible sometimes to find the original password. And this is the password of the new user, encrypted password of the new user that I just created. Now, we can change the ownership of one file with the command change ownership. For example, let's create again the file foo.txt. Foo.txt. The ownership of this file is user1 because I created it. Now let me try with change own root foo.txt. So I want to make this file be owned by the user root. But it says operation not permitted. So this command change own can be executed only by a super user, by an administrator. So let me try with sudo, and then lsl foo.txt, and now the owner of this file is root, because it says change owner to root for this file. And actually, I can change both the ownership and the group, and separate them by a semicolon. So change own root semicolon root foo.txt. I changed both the owner and the group. And if the owner and the group are the same, then I can use this command, just change root semicolon, and then the group will be the same as the owner. For example, change owner, let me change it back to user1, which is my user, or test1, say test1. So it is changing the ownership and also the group, but the group is the same as the owner. So I just use the semicolon and don't write anything. So it belongs to user1 and group user test1 and group test1. Now let me try to remove this file. Remove write protected regular empty file. Yes. Just removed it. Now we will see an example with permissions. And first of all, let's explain what we are going to do in this example. In this example, we suppose that we have two users, for example, Bill and Karen. And they want to store their music files, and they want to use a common directory, a shared directory for storing these music files, which means that they both should have write permission on this directory and also read permission on this directory. So first of all, we are going to create these two users, and then we will create a directory with the correct permissions so that both of them can share files in this directory, music files or some other files. So since most of the commands that I'm going to give in this example need super user permission, then I'm just becoming a super user, and then all the commands that I will type, I don't need to write sudo in front of it, because I'm just the root user. Who am I? I'm the root user, and I don't need to type sudo every time I give a command. So first of all, I will create the users Bill and Karen. User add, create home directory, shell bin bash Bill. So I've created the user Bill. here I have the new user build. Now user add, create home directory, use shell bin bash, username Karen. Here is the new user, Karen. And if I check with tail, I get the last 10 lines of the given file. So the last 10 lines of the file /etc/password. And I see here that there are 2 new lines in this file for these 2 new user accounts that I've created. And this is the shell, and this is the home directory. And now I will create a new group, and I will test these 2 users in this group, so that in order to facilitate the sharing of files between them. So I will create a group called music. Group add music. So I created a new group music, and if I tail etc group, I see here the last line is for the new group that has been created. So when I created user build, it also creates a group build by default. And when I created the user Karen, it also created a group named the same as the user, which is the default, which will be the default group for this user. And now I've created another group music, and I'm going to add these 2 users to this group. So add user user build to the group music. Add user Karen to the group music. So I added both these users to the group music. Let's check with tail etc group. Now we see that at the group music, we have these 2 users, Bill and Karen. Now I will create a directory that will be used to share the music files. And I will create it in the directory user local share. So in this directory, Control A, make dir, create a new directory, music. So now in the directory user local share, I also have this new directory music that will be used to share music files. And if I check the permissions of this directory, first of all, I see that this D here tells me that it is a directory. It has a read-write execute for the owner, but actually it belongs to the user root and to the group root. So the users Bill and Karen cannot use this directory. So I have to fix this, and I will change the group of this directory to music, and the group can be changed with the command change mode. But now I am specifying only the group. After a semicolon comes the group. So I'm not changing the user, I'm changing only the group, change mode music for directory user local share music. Not change mode, change on. Change mode is changing for permissions. Change on is for changing users and groups. So if I check the directory permissions and ownership, now it belongs to the group music. But I also I need also to change the permissions so that the group has read and write permission and also execute. So the members of group music, which are Bill and Karen, have read and write and execute permissions on this directory. So let me use the command change mode now, 775. Music. And let's check again the ownership and permissions. Now the group has full access, read, write, and execute. So the members of the group music can read the content of this directory, can write, can create new files in this directory, and also this X means for the directory it means you can see the content. Yes. Now let's try to create a new file as user Bill. First of all, I will become user Bill. This command su means switch user to group Bill, and this -L option means login. It means login. So it will be the same as I login with the username and password to the account Bill. And now also the prompt, the change of the prompt shows me that I'm in another account. But I can also use the command who am I? I am Bill. And now I will create, as user Bill, I will create a new file in this directory. So this is for creating a new file, user local share music, and I'm calling it test1. Now let me check the permissions of the new file. Now we see this new file test1. It actually belongs to the group Bill, but if it belongs to the group Bill, it does not have enough permissions for the user Karen. So user Karen can see this file, but cannot maybe cannot edit it. Or so actually, I don't want the group of the file that is created to be Bill. I want the group of the file that is created to be music, because if it is of group music, then all the members of the group music can have access to this file. So how can I fix it? I can fix this by giving a special permission. First of all, let me exit from user Bill. Now I am super user and root. By giving a special permission to the directory user local share music. Change mode group plus S. So I'm adding this S permission to the group, which is a special permission or a sticky bit. It is also called sticky bit. Share music. So lsl user local share music. Actually, I'm adding the option D so that it shows the permissions of the directory. It is listing the directory itself, not the content of the directory. So this command is listing the content of the directory, but I just want to get a listing of the directory itself. So that's why I'm adding this option D, -L, -D, to list the directory itself, not the content of the directory. And so here we have the S permission that we added. So instead of X, we have this S permission or sticky bit. What does it do? This sticky bit makes possible that when a file is created inside this directory, then it will get the same group as the directory, not the group of the owner, because if a file is created, usually the new file gets the ownership or gets the group of the owner. So if the owner, which is Bill, belongs to the group Bill, then the new file that is created has the ownership Bill. But with this S bit given to a directory, a new file that is created inside this directory will have the same group as the directory itself. So if the directory has the group music, then the files that are created inside this directory by default will have the group music. And this is what we want to achieve. We want to achieve this because if they have group music, then all the users of the group music can have access to these files. All that access, read, write, and execute. Now that we added this sticky bit, let's check, let's test again and create a new file, another new file. So Bill. Now I am as user Bill. Let me create another file, test2, inside this directory. Test2. And let me check the content of the directory. Now you see that this new file that we just created has the group music. So when we create it, it gets the same group as the directory itself. And this happens because we gave the sticky bit or the special bit to this directory. And now we will see processes in Linux. Actually, this is a long session, but we will just start today, and then we will continue it in the next meeting, maybe. So what is a process? A process is a program that is being executed by the system. Linux is a multitasking system, which means that it can run many processes at the same time. And if there is only one processor, actually only one process can be executed at a certain time. However, the Linux kernel can switch quickly between different processes, allowing each of them to run for a short time. And because this happens very fast, it gives the impression that all the programs are running in parallel. So let's say that 3 processes are being executed in the Linux system. So the processor, the CPU, executes the first process for a short time, then stops it, executes the second one, stops it, executes the third one, stops it, executes the first one again, stops for some time, for a short time, the second one, the third one, and so on. And the CPU does it so fast that it seems that all the three processes are being executed in parallel. Actually, the more modern systems don't have just one CPU. They have multiple CPUs. For example, they can have 4 cores or 16 cores, or 12 cores, and so on, which means that there are 16 different processors or 12 different processors in the same system. But even if it was just one processor, this is how it is done. And even if there are multiple processors, they switch tasks or processes one by one, execute one for a short time and then switch to the other one. Let this one execute for a short time and then switch to the other one, and so on. And so it seems that all the programs that, or all the processes that are being executed in the Linux system are being executed in parallel. Each process in the Linux system is started by another process. The process that starts it is called the parent, and this is called the child process. So there is a hierarchy of all the processes in Linux, parent, child, parent, child. It looks like a tree. And at the top of the tree, there is the main process, or the root process, the initial process, which is usually called init. This is the init process. So when we start the Linux system, it is executing the init process, the initial process, and the init process starts the other processes, some other processes. One of them is, for example, the terminal, where we give the username and password. And in order to log in to the system. And once we give the username and password, the terminal process starts a shell, starts the bash. And once we get the bash, we give several commands, and each command that we give starts another process. And the parent of the processes that are started by the commands is the shell, because from the shell we give a command and start another process. So all the processes in Linux are organized like a tree. There is a hierarchy of processes. We can use the command ps to see a list of processes. But actually, this command ps without any arguments just shows my processes, the process of this user, and on this terminal. This PID, process ID, each process has an identifying number, a unique number, which is called process ID. So there is a number that identifies each process. And TTY means terminal, and terminal PTS/1 is the current terminal. So when I give the username and password, it is the terminal that is asking me for the username and password, and then it starts the bash. The bash is the shell that we are giving commands. And then from the bash, I type the command ps. It is this. So this is just showing my own processes in this terminal. If I use the option A, this A means all the terminals. So we see the processes on terminal PTS/0, PTS/1, PTS/2, PTS/4, and so on. So these are other terminals that you are using. For example, this is my terminal, PTS/1, the terminal that I use to log in. And /0, /2, /4 are other terminals. And I see that somebody is using the command top. Probably this is Anton, because Anton knows about it. So Anton is using the terminal PTS/2. And this option -a is showing also the time of execution. So how much this process has been, how much CPU is consumed by a process. And if I use the option U, if I add the option U, PS AEU, it is showing also the user. So now I can see clearly which process is executed by each user. And it also adds some other columns. These columns. It is adding this. This is percentage of CPU that is being used by each process. Percentage of memory. Maybe this is the size used by the process. I'm not sure. TTY, we have seen it is the terminal. And this is the state of the process. S means sleeping. R means running. So right at the time that this command is executed, the command itself has been running. And in order to see more options about the PS command, we can use the command help, PS --help. But I think that the time is up for today, so let's stop it here, and we will continue on Friday with processes and other things. So let me stop recording.